Good evening children. Today we are learning a new lesson 4.7 explaining neutralization. The objectives are: the first objective is to name the product of neutralization, and the second objective is to describe the product of neutralization of different alkalis and acids, and the last and the third objective is to suggest the pH of the product of neutralization. Here we are going to discuss about the neutralization between sodium hydroxide and hydrochloric acid. The neutralization reaction we already learned in the previous lesson. Here the alkali is taken, it has sodium hydroxide, and the acid is hydrochloric acid. When sodium hydroxide is reacted with hydrochloric acid, the product we know, the salt and water. Here the water H2O. H2O means it is water, and one of the salt is formed, it is sodium chloride. Because we take sodium hydroxide and hydrochloric acid, so the salt formed is sodium chloride. And next we are going to discuss about the product of neutralization that we already discussed the previous lesson, and these lessons are connected each other. So here the product of neutralization, we can start it from the general equation. Acid plus alkali is equal to salt and water. So the product of neutralization are salt and water. It is same in all neutralization reaction. For all neutralization reaction, the product formed is salt and water. Now we are discussing some of the examples of neutralization. The first example is magnesium hydroxide plus hydrochloric acid. Product is magnesium chloride and water. See, the previous example we used sodium hydroxide, so the salt we got is a sodium chloride. But here we used magnesium hydroxide, so the salt formed is magnesium chloride. Another example, potassium hydroxide plus nitric acid. So here the acid is different. Before we used hydrochloric acid, here we are using nitric acid. The product is potassium nitrate plus water. And the second example, that is sodium hydroxide plus sulfuric acid. The product is sodium sulfate plus water. See, in these three equations, everywhere the water is same. Water is the one of the product. So we can tell water is the common product formed during all the neutralization reaction. But see the salt formation. The salt formation, everywhere we got salts, but the name of the salt is different. Why it is different? Because we use different types of acid and we use different alkalis. The first one we use magnesium hydroxide. Second one we use potassium hydroxide. In third example we use sodium hydroxide. So respective salt is forming. That means in every equation we are getting salt, but the name of the salt is different. That means the salt is not a name for a particular compound. It is the general name given for one group of compounds. So the salt is produced depends on the acid and alkali that were reacted. So this is the main thing about the neutralization reaction. Generally we can tell for every neutralization reaction salt and water is forming. But every neutralization common product is water. But the different product formed depends on the acid and alkali, that is salt. Now we are discussing about the formation of water from neutralization. We already discussed water is one of the common product formed during neutralization reaction. Here is the picture to show how the formation of water taking place. See, the first one, it is an example of acid, and the second one, it is an example of alkali. Water is formed by joining hydrogen from acid and hydroxide from alkali. Because we know acid, it contains hydrogen is the common ion, and alkali, it contains hydroxide is the common ion. So, hydrogen from acid and hydroxide from alkali joined together to form water during neutralization reaction. Next, pH and neutralization. What is the relation between pH and neutralization reaction? Then we know the neutralization reaction, the product formed is neutral and its pH is 7. Acids have low pH and alkalis have high pH. The product formed should have a pH 7. That means here we are taking one of the acid. See the pH of the acid. The pH of the acid is equal to 1. That means it has the lower value. Lower value means it is a strong acid. The same way the pH of alkali is 13. The pH of alkali 13 means it is a strong alkali. That means here one strong acid is reacting with strong alkali. So the product formed should be a neutral product. Next, suggest the pH of pure water. We know the pure water is having pH 7. Pure water means only the water molecules are there. Nothing is added. So the pH of the pure water is 7. But the drinking water, we are drinking water, it is pure, but it is added with some of the minerals and gases. So if we are adding some minerals or gases in drinking water, the pH will be slightly changing. Depends on the minerals or gases in it, the pH of drinking water is slightly alkaline or slightly acidic. Now we finished our all the three objectives. I hope you all understood the lesson. Thank you. Thank you and have a nice day.